Hi, Honors Algebra 2 Trig. Today we're going to be doing the law of sines. The law of sines and the law of cosines are ways for us to solve triangles that are not right triangles. So any acute or obtuse triangle is considered to be an oblique triangle. An oblique triangle is any triangle that is not right, meaning it does not have any right angle. We can't use regular trig with these. SOHCAHTOA only works when we know that we have a right angle. In order to be able to use law of sines or law of cosines, we have to know some very specific information about the triangle that we're working with. First case, if you know one side and two angles. So one side and two angles, you could have angle, angle, side, or you could have angle, side, angle. And if you recall from geometry, those were two of the theorems that you were allowed to use in order to prove that two triangles were congruent. I'm going to skip case 2 and come back to that one. In case 3, you could have two sides and the included angle. So side, angle, side. Another one of our geometry theorems. And you could also have case 4, all three sides. If you know the measures of all three sides, we can use this to find the angles, and that would be side, side, side. Now, the last case that I skipped was something that we were never allowed to do in geometry. Two sides, side 1, side 2, and the angle opposite one of the sides. This was side, side, angle, or if you spelled it backwards, something that we shouldn't say in class. So in this case, you weren't allowed to use it in geometry because there's ambiguity about it, and we're going to talk more about that in just a minute. In order to solve cases 1 and 2, we're allowed to use what's called the law of sines, which is what we're focusing on today. In order to solve cases 3 and 4, we're going to use the law of cosines, which we'll do in class tomorrow. For the law of sines, you have a triangle with three sides, little a, b, and c. The angle opposite the side is given as a capital letter, capital A, capital B, capital C. You can set up three equal ratios. Depending on what information you're given, you would choose any two of those ratios to create your formula. So you would have the sine of A over little a equals the sine of B over little b equals the sine of C over little c. And you can choose any two of those that you would like to use. Incidentally, the reciprocals also work. A over sine A equals B over sine B equals C over sine C. That's also legal. But you could never have one of the pink ratios equal to one of the green ratios. You have to always make sure that if the sine of the angle's on top and the side's on the bottom, that they're in the same kind of location. So let's try this out, okay? So first example, we're going to find all the missing pieces on this triangle, and we're given that angle A is 64 degrees, angle B we don't know, and angle C is 82 degrees. So first thing I'm going to do is draw a picture. I am not super specific about this picture. It's almost equilateral. Doesn't matter. It doesn't have to be in proportion. So here's A, 64 degrees. Here's B, and here's C, 82 degrees. I know that side C is 14, so I go, here's angle C, side C is directly across. Here's angle B, side B is going to be right here. Here's angle A, side A goes right here. We're allowed to use any of the things we learned in geometry to help us out with this. So the first thing that I'm going to do is find angle B using what I know about triangles. The sides of the angles of a triangle add up to 180. So angle B plus 64 plus 82 equals 180. So 180 minus 64 minus 82, the measure of angle B is 34 degrees. And I'll fill that in over here and in the picture. All right, the last two pieces that are missing are side A and side B. And to do that, I'm going to use my law of sines. So I know angle C and side C, so that's the ratio I'm going to set up first. Sine of 82 over 14 equals the sine of 64 over little a. And I can solve this by cross multiplying and then dividing to get little a by itself. So a equals 14 times the sine of 64 divided by the sine of 82. I'm going to pop that into my calculator. Make sure that you're in degree mode. Remember, we were working with radians recently, so you might not be. So sine of 64 divided by the sine of 82. And I end up with A is approximately 12.71. And I don't know the units. Oh, I do know the units. They're inches. If you don't know the units, you don't have to label them. Great. So now we're going to do it with B. So I'm going to go back to the ratio for C, and this time I'm going to show you what I was talking about, how the reciprocals work exactly the same way if you need them to. So instead of putting little b on the bottom, I'm going to put little b on the top over the sine of big B, 34, and that equals C on the top, little c on the top, over sine of 82. So the reciprocal of the ratio also is equivalent. And this one, it's a little easier to see that I'm multiplying both sides times the sine of 34, and this is what's going into my calculator. So 14 times the sine of 34 divided by the sine of 82, and this time B is 7.91. You want to make sure that you are very organized because these could really quickly get messy. So this was where I found my angle, this is where I found side A, and this is where I found side B. If you want to put them in boxes or clusters, just make sure that it's really easy to see. And the other thing that I'll try to do to help you is have an answer blank. A lot of the time I'll have an answer blank, so there's a place for you to show that. And if you need more space on your paper, feel free to use extra scratch paper. Okay, next example. So here's this triangle. Again, not super specific about the shape of it. Label A, B, and C. Across from B is 12 feet. C is 22.5 degrees. And A is 40 degrees. And I'm looking for little a and I'm looking for little c. Oops. Okay, so if I know the two angles, I'm going to subtract from 180 to find the other angle. So the measure of angle B is 180 minus 40 minus 22.5. So B, we have 117.5. And I meant to say this before I started, but take a minute, try this on your own. Sub, feel free to pause the video and give them a chance to try this. See if you can set up the two ratios for finding the side A and side B without my help. And then push play again and see if you've got the right answer. So I've got 12 times the sine of 40 divided by the sine of 117.5 as my first one to find A. And be careful with parentheses in your calculator. Depending on the calculator that you have, you need to make sure you close the parentheses around your sine input value. So I get that A is approximately 8.69600. I've been rounding to 2 decimal places, which I will continue to do. So I'm going to do 8.696 rounds up to 8.70. In order to prove to me that you rounded to 2 decimal places, you have to include that 0. You can't just put 8.7. Okay, so that's this group. Now my last part I have to do for side C. So C over the sine of 22.5 equals, I like to go back to the non-rounded number. We talked about it earlier in the semester. You only round once. So I already rounded 8.70, so I don't want to use that if I don't have to. I want to go back to using the 12 feet, and the 117.5 is exact, not rounded. So the sine of 117.5. All right, so for this one, we have 12 times the sine of 22.5 divided by the sine of 117.5. And for this one, I get 5.177, that rounds up to 5.18. So when we have angle, side, angle, or angle, angle, side, it's pretty easy. We find the missing angle, no big deal finding the rest of our answers. The ambiguous case is the one that gets a little complicated, okay? So let's talk through this. In an angle, side, side triangle, the problem that you have is that we lock down the first angle, and we know how long this side is. But the third side right here, we have no idea. We know how long it is, but we have no idea where it swings. We don't know where it goes. And there are options for where it could hit. So you could have a triangle where there's only one possible ending. This is the only place that line could go. Or you could have a triangle like this one, where we've locked down the angle, we know the first side, and watch what happens with the second side. The second side, if I'm keeping it the same length, and I'm thinking about it swinging on a hinge, like this, I could have this obtuse triangle, or I could have this acute triangle, depending on where my end lands. And so this actually has 2 triangle possibilities. So you could have one triangle, you can have 2 triangles, or there's even the case with angle, side, side, that this side is just too short. It doesn't matter how I swing it, it never hits the opposite side, and therefore I have 0 triangles. So as we solve the ambiguous case, we have to kind of think about all those different possible solutions that could happen and then figure it out. So the general rule of thumb is solve like there's only one, if you can. If you figure out that there is no solution, you'll be able to stop right there knowing that it was 0 triangles. Then you test to see if there's a possibility for 2 triangles. You take 180 degrees and subtract the first angle. Then you add the angle that you were given in the beginning and see if the sum adds up to 180, if it's greater or less than 180. I'll show you how that works in these next problems. Okay, so I apologize. It put in the same problem twice, which is ridiculous. So I'm going to white out the second half of this problem. There it is. Doesn't exist. Okay, so first triangle. This is a case that only has one solution, and I'll show you how we can test for this all along the way. So draw a triangle. Place the given angle here every time, no matter what the letter is. So whether it's A, whether it's B, whether it's C, doesn't matter. So this is 123 degrees. Then I know that side A is 47 across from angle A. And now here's the trick. In order to get a picture that makes sense, you're going to put side C so that it looks like angle side side. 23 goes right here, which means C is right here and B is right here. This is little b. Let me walk through that again because setting up the picture is really helpful. You lock down your angle. This is flat on the ground. This is your first angle. Across from that angle, you're going to have a side. Fill it in. Whatever your other side is, even if it's not in the same order that we usually do it, put that side so it goes angle, side, side. Then label appropriately all the missing pieces. Okay, so now we do law of sines just like usual. I can't find an angle, so I'm going to have to set up the law of sines and say that the sine of 123 degrees over 47 equals, and I'm going to do C, the sine of C over 23. Now when I go to solve this, 23 times the sine of 123 over 47 equals the sine of C. The only technique I have for finding angle C is by using sine inverse. So the measure of angle C equals sine inverse of all of that. 23 times the sine of 123 divided by 47. And I'm going to show you how I do this in my calculator so that I don't have to type it all in too much. So the first part, this I'm going to do in one step. So 23 times the sine of 123, close my parenthesis, divided by 47. Now I'm going to use sine inverse because I'm trying to find an angle, and I'm going to use second answer so I don't have to type that all in. So now I know that the measure of angle C is approximately 24.23 degrees. So all of this was my first step. So I'm going to put that 24.23 degrees. And I'm worried I'm going to run out of room, so I'm going to shrink my writing. What did we do before iPads? Ooh, I forgot I had that white out behind it. That's okay. I can do more white out. Okay. So now we know two angles and two sides. And in order to find that third section, I'm going to have to use what I know about triangles and find the missing side. So I do 180 minus 123 minus 24.23 to get my angle. And that comes out to be 32.77 degrees. Now I want you to remember we rounded here, right? So this angle, B, is a rounded angle. So depending on how many decimal places you rounded C, or if you even use the exact values, you might have a slightly different decimal. All right, last bit, we're going to find we're going to find side B. So we'll do sine of 123 over 47 equals sine of 32.77 over B. Cross multiply and then divide. So B equals 47 times the sine of 32.77 degrees divided by the sine of 123 degrees. And that's what's going in my calculator. So 47 sine 32.77 divided by the sine of 123. So B is approximately 30.33. Okay, so we found one triangle. Now we have to stop and see, wait a minute, is it possible that there could be a second triangle. So the way that we find out if there's a second triangle is we take 180 degrees, 180, minus the angle that we found. The angle that we found was 24.23. We add the given angle, the one that we started with, which was 123. And if that number is greater than 180, we only have one triangle. So greater than 180 degrees equals one triangle. Let me show you why. Coming back to this picture right here. If this angle was our 24.23 degree angle, thinking about whether the side lands here or here, that's an isosceles triangle. This is 24.23. So I'm either looking at this obtuse triangle, let me outline it for you. This obtuse triangle is the hidden second triangle. We found this big one. We're checking to see if this obtuse triangle exists. And the way that we check is to see if the original angle, which I know this is completely not to scale, if the 123 degree angle plus this obtuse angle, 180 minus 24.23, 155.77, could they possibly form a triangle, an actual triangle? And the answer is no. That already adds up to more 180 degrees. It's never going to create another triangle. And that's why that is not more than one case. It's only one triangle in that. Now I'll show you an example where there are two triangles. Okay, so this one has two solutions. So I needed both of those to show you the two solutions. I'm going to draw the triangle off to the side because I like visualizing this. So here's my triangle. I always put my angle that I'm given on the left. Lock in your angle. Across from that is the side that matches. So this was A. And then, even though it's not necessarily the same order we do, the side that you know, put right here because we want it to go angle, side, side. Okay, that means that this is B, this is C, and this is little c. So let's solve our first triangle like we always do. So we're going to do the sine of 35 over 12 equals the sine of B over 16. So the sine of B is 16 times the sine of 35 over 12. And then I'm going to use sine inverse in my calculator to find the rest of it. So there's my calculator. Okay, so I do 16 times the sine of 35 divided by 12. And then I use my calculator to do second sine inverse of the answer. And I get that the measure of angle B is 49.89 degrees. Okay. So now we're going to follow the same thing we've been doing to find C. And I'm going to continue working on this side so I leave myself space over here for the other one. So to find angle C, where's my calculator? 180 minus 35 minus 49.89. Oh, come on, Mrs. O'Connor. Use a minus. There we go. So this is 95.11. And yes, if you're using your calculator for this and you don't show your work for that, I'm not going to be real mad about it. That's fine. Now we're going to do sine of 95.11 over C equals the sine of 35 over 12. Cross multiply, Do your dividing. 12 times the sine of 95.11 over the sine of 35. And what do we get for this one? $20.84. Okay, so now I want to show you visually how to look at this ambiguous case. Okay, so let's look at how we find that second triangle. So if we go back to the visualization, the picture that we've been working with, remember we talked about this side, the length of 12, could have swung in this direction and made that obtuse triangle, where the 12 is here, and instead of angle B being on this side, angle B is right here. If that's the case, we think of this as an isosceles triangle, which it is, and the 49.89 degrees is on the outside of the triangle. So in order to find that other angle, we have to do 180 minus the 49.89, and that's where we get 130.11 as the obtuse angle. That's angle B. So let's label that 130.11 degrees. If this is a real triangle, we should be able to find angle C in the same way we find any other angle in a triangle. So 180 minus 130.11 minus 35. Oops, that's 130. And we get 14.89. 14.89 is angle C. And now we're left with the last bit, using the law of sines to find side C. So C2, because this is our second triangle, over the sine of 14.89 equals 12 over the sine of 35. C2 equals 12 times the sine of 14.89 divided by the sine of 35. And so C2, that missing side, is 5.376 rounds to 38. 5.38. In the case where there's no solution, when you try to find that angle, you're going to get an error. It's going to cause a problem. So what happens in this one, here's our triangle. We lock in angle A as 50. Across from A is 10. We lock in the other side right over here, 20. That means that this is B. Let's move this a little bit. So this is B. And then the other part, this is C and this is little c. Okay, so the first part we're going to find is angle B. So we put that the sine of angle B over 20 equals the sine of A over 10. And when I solve this, the sine of B equals 20 times the sine of 50 divided by 10. Now, instead of putting this all in my calculator in one step, I want to show you two things. If I put this in my calculator all in one step, it's going to give me an error. I'm going to do sine inverse of 20 times the sine of 50 divided by 10. But if I just do 20 times the sine of 50 divided by 10, I get a value. I actually get a number, 1.53. The reason why this creates a problem when we do our sine inverse is because sine values can't be larger than 1 or smaller than -1. We saw that when we worked on the graph of sine yesterday. It's limited in its range between -1 and +1. So when we ask what angle gave us an answer of 1.5 for the sine, the calculator goes, no, silly, no angle gives you that value. It's not possible. That's why there's not a real answer. So we say no solution, no triangle, or not possible. Any of those is fine. Obviously, the trickiest one for this is the ambiguous case where you have to find that second triangle. So be careful, practice those. Tonight's homework has some law of signs, and it also has some mixed review in it. So make sure you try it. It's on Schoology, and I'll see you guys in class tomorrow.